Hey everyone, welcome. Today we're going to talk about something that's, honestly, a huge deal in machine learning, how to build models that you can actually trust. You see, it's one thing to build a model that looks good on your screen, but it's a whole other challenge to make one that works out in the real world. So, let's get into it.
This really is the million-dollar question, isn't it? This is what separates a data science project that's just a cool experiment from one that delivers real, actual value. So how do we make that leap? Well, that's exactly what we're going to figure out together today.
Okay, so here's our game plan. First up, we'll talk about the main challenge you face when you're building any model. Then, we'll get into this awesome quality check called cross-validation and explore a few different ways to do it. After that, we're going to switch gears and talk about why pictures, visualizations, are so incredibly important. And we'll wrap it all up with a quick tour of the charts you absolutely need to know.
All right, first things first, building a model. It's really a journey, right? You're taking all this raw, messy data and trying to turn it into something that can make smart predictions. But like any journey, there are definitely some bumps and pitfalls along the way that we got to watch out for. So as you can see here, building a model isn't just poof, one magic step. Nope, it's a whole process, a sequence of steps from figuring out the problem all the way to tweaking the final product. But for today, we're going to laser focus on step number 6, evaluate the model. I mean, this is the moment of truth, right? This is where we find out if all that work we put in was actually worth it. Okay, let's paint a picture. Imagine you've built your model, you've trained it, and bam, it's showing 95% accuracy on your training data. That sounds amazing, right? Like, pop the champagne, we're done here. But hold on a second, not so fast. That number can be a total trap, and I'm going to show you exactly why. This picture here shows the two big enemies of any good model. Over on the left, you've got overfitting. I love this analogy. Think of it like a student who just memorizes every single word in the textbook. They can ace a test if the questions are identical, but ask them something slightly different, they're lost, and has what we call high variance. It's just too fixated on the training data. Then, in the middle, you have underfitting. This model is the opposite. It's too simple. It has high bias, meaning it didn't even learn the basic pattern in the data. And what we're always aiming for is that beautiful sweet spot on the right, a model that gets the general idea, the main trend, without getting bogged down by every little detail. So the big question is, how do we find that perfect Goldilocks zone? How do we make sure our model isn't overfitting or underfitting? Well, this is where our hero of the day swoops in, cross-validation. Seriously, think of this as the ultimate quality control check for your model. So what is it really? At its heart, cross-validation is all about one thing, figuring out how well your model will do on brand new, totally unseen data. It's like a dress rehearsal for a play, or maybe a better way to think about it is a stress test. We're simulating what's going to happen when we finally let this thing out into the real world.
And the basic idea behind it is actually pretty simple, but it's super powerful. Instead of throwing all your data at the model for training, you're smart about it. You hold a little bit back. You train the model on one chunk, that's your training data, and then you test it on the piece it's never seen before. That's your test data. But here's the key. You do this over and over again to get a really solid, reliable score of how good it actually is.
Okay, so cross-validation isn't just one single thing. It's more like a family of different techniques. So let's go ahead and open up our toolkit and check out a few of the most popular and useful methods that you're probably going to run into. Just to give you a quick overview, first there's K-fold. This is like the dependable workhorse of the group. You'll see it everywhere. Then you've got something called leave one out, or LOOCV for short. It's kind of the extreme version, and it's really best when you have a super small data set. And last but not least, there's bootstrapping. It works a little differently, and it's awesome for checking how stable your model is. So let's kick things off with K-fold. It might sound a little technical, but the process is actually super logical. Here's how it works. First, you take your data and you chop it up into a few groups, which we call folds. Maybe 5 or 10 folds. That's pretty standard. Then you take all but one of those folds and use them to train your model. The one you left out, that's your test set. Then you do it again, but this time you pick a different fold to be the test set. You just keep repeating this until every single fold has had a turn being the test set. And at the very end, you just average all the scores together to get one really solid number.
And this picture here just lays it all out perfectly. You can see the data getting split again and again. Each time, a new little section gets to be the test set. The brilliant part is that this makes sure every single piece of your data gets used for testing exactly once. And trust me, this gives you a way more reliable idea of your model's accuracy than just doing a single, simple trained test split. Okay, so what happens if you take this k-fold idea and just push it to the absolute limit? Well, you get leave one out cross-validation, or LOCV. It's exactly what it sounds like. If you have, say, 100 data points in your dataset, you create 100 folds. For each run, you train the model on 99 of the points and test it on that one single point you left out. And you do this 100 times. Yeah, it takes a lot of computing power, but if you're working with a really tiny dataset, it's an amazing way to squeeze every last drop of value out of it. Now, don't worry, you don't need to be a coding whiz to get this. Just look at what the code is doing. For a tiny dataset with just 10 points, it's making 10 different splits. See? First it tests on that first data point, then the second, and so on all the way through. It's just a clean, automated way to make sure you test on every single data point one at a time.
All right, our last technique is called bootstrapping. And this one has a really cool twist. Imagine you've got a bag of marbles. You reach in, pull one out, check its color, and then, and this is the most important part, you put it right back in the bag before you pick the next one. That's called sampling with replacement. We do this over and over to build new data sets. Why? Because it lets us see how much our model's predictions jump around when the data changes just a little bit. It's a fantastic way to get a feel for how stable and certain our model really is.
Okay, so we've established that cross-validation is our go-to for quality control after we've built the model. But what about before? You know, the ingredients we're using? Because a truly great model always starts with understanding your data. I mean, really understanding it. And the absolute best way to do that is by looking at it through visualization. That old saying is true, a good chart is worth 1,000 data points, maybe more.
Let's start with an old-school classic, the histogram. It might look simple, but man, is it powerful. All a histogram does is take one of your variables, say age or price, and it groups the numbers into different ranges, or bins. Then it just shows you a bar for how many of your data points landed in each bin. Instantly, you can see the overall shape of your data. It's awesome.
Check out this example right here. This histogram is showing the percentage of people over 65 in a bunch of different counties. Just by glancing at it, you can immediately tell that for most counties, that number is somewhere between 15 and 20%. See how it's kind of shaped like a bell, but it's got that little tail stretching out to the right? Trying to spot that pattern just by staring at a spreadsheet of numbers would be way, way harder.
Now, if we want to get a bit more precise about how our data is spread out, we can use something called quartiles. It sounds fancy, but it's easy. Just imagine you took all your data points and lined them up in order, from the smallest value to the largest. Quartiles are just the 3 points that chop that line into 4 equal-sized chunks. Right away, this tells you exactly where the majority of your data lives.
And this diagram just makes it super clear. That Q2 right in the middle, that's your median, the exact halfway point of your data. Now that whole middle section from Q1 to Q3, that's called the interquartile range. And that's where the middle 50% of all your data is hanging out. It's just a great way to see the spread and, more importantly, to easily spot any values that are way, way outside that main group, what we call potential outliers.
So, histograms and quartiles are just a couple of the tools in our visual toolkit. But having the tools is one thing. How do you use them the right way? Well, the key is to have a system, a structured process. So let's quickly go through a simple roadmap you can follow for pretty much any data set you come across.
Think of this as your checklist, your step-by-step guide. First, you get your data organized. Simple enough. Then, for each variable, you figure out its center and how spread out it is, using medians and quartiles like we just talked about. Then, you make some pictures. You visualize it with histograms, keeping a sharp eye out for anything that looks weird, those outliers. And finally, and honestly, this is where the magic often happens, you start looking for connections between the different variables. This whole process is how you stop looking at numbers and start seeing the stories that your data is trying to tell you.
So, there you have it. We've gone through how to build a model you can actually count on using things like cross-validation, and we've seen how visualization can help you get to know your data on a much deeper level. You've got the tools now, they're in your hands. So I'll just leave you with this question. What story is hiding in your data, just waiting for you to find it? Thanks for joining me.